Worksheets 54 and 55, writing binary formulas and naming binary compounds. Here we're going to take the chemical symbols and the oxidation numbers of the elements and combine them first to come up with the correct chemical formula. And then in just a little bit, to use the formula to write out in words the names of each compound. Well, first remember that oxidation number is what the atom will likely do with the valence electrons. So I'm going to go ahead and scroll down a little bit. As you see, question number 1 says sodium +1, chlorine -1. Well, remember the oxidation number +1 means that atom is going to give away one valence electron. Chlorine has -1, that atom will take that one valence electron. And that is why you see the +1 for sodium and the -1 for chlorine. Now remember, and you still see it on the screen, make the positive and the negative match so that they will cancel each other out and we'll get a grand total oxidation of 0. 1 and -1 give us that 0. And I like to say it like this: +1, -1, already done. So all we have to do is write that final formula right there of sodium chloride. All right, I'll go through the ones that you already see work, then I'll do a couple more with you, and then I'm not going to steal all the fun. I'll save a little bit for you. Barium is +2, so we put the +2 here. Fluorine is -1. Now the thing is, +2 and -1 do not make 0, so what we have to do is make these two match so we get a cancellation out to 0. So how are we going to increase -1 to match a +2? Well, if I had -1 twice, then I'll have a total of -2 right here. So then it's +2 and -2, and that gives us 0. So what it happened was it took 1 barium and 2 fluorines to complete this compound. To me, that's a lot nicer than trying to do the electron dot notation. All right, go back to number 1 where it says +1, -1, already done. All we had to do really is copy the symbols. Now look at number 11. Notice that iron says +2. Well, iron is a transition metal that could have more than one oxidation number. I'll get to that in a moment. Oxygen is -2. So iron in number 11 will give away 2 electrons. Oxygen will take 2 electrons. Does this already equal 0? +2, -2, equals 0, so this one is already finished. Hence, FeO, iron 2 oxide. +2, -2, nothing more to do. Well, now look at number 12. We have a +3 and we have a -2. Now remember, fractions aren't allowed here, which I'm sure you like. You don't have to deal with fractions when doing these oxidation numbers. That's a good thing. But can we bump a 2 up to make it a 3? Can we say 2 times 1 is 3, 2 times 2 is 3? That won't happen. So what we have to do is find the least common multiple, and the LCM of 3 and 2 is 6. So what we want to do now is make each atom have a total oxidation of positive or -6. Well, so what we need is this +6 to go here and this to be a -6. Well, see the +3? How many of those will make +6? That answer is 2. See the -2? How many of those will make -6? That answer is 3. Therefore, it takes, and you can see this right here, 2 irons and 3 oxygens in order to make iron 3 oxide. Now you might remember from the notes, when I say iron 3 oxide, I'm talking about the oxidation of iron being the +3. A moment ago, I said iron 2 oxide. I'm talking about this oxidation number of iron being 2. So the Roman number is the oxidation being used for that particular metal. Now I'm going to clear this off and show you an even faster way to do number 12. Look at it again. See the +3 right there? It ended up here on the oxygen. See that -2 right here? It ended up right there on the iron. Remember from the notes, I said this, 3, 2, switcheroo. Those 2 oxidation numbers simply switch places, and we drop the plus and minus signs. We can do that with binaries. only 2 elements, and therefore we get Fe2O3. Now look at number 14, which is exactly like number 12. See that plus 3? It goes here. See that 2 right there? It goes here. So this answer is going to be Cr2S3. So remember this little rhyme, 3-2 switcheroo. And it wouldn't matter if the 3 was written first or the 2 is written first. 3-2 switcheroo, they're going to trade places. Now let's do it the long way to show you why that works out. Still doing question 14, chromium and sulfur. Just like in number 12, the LCM of those two numbers, 3 and 2, is 6. So how many 3's make 6? 2 of them do. How many 2's make 6? 3 of them do. That means a positive 6 and a negative 6 will give us a total of 0. And just like we had a moment ago, that means copy this. Running out of space, but you get the idea now. Cr2S3, and that is your answer. All right, let's try number 3 and number 4. Potassium +1, sulfur -2. So what we have to do is bump up. We always bump up. We never go down. So I have to bump this +1 up to make it +2 to match the -2 and give us our 0. And as I said in the notes, this is the only time I want you to get a 0 on the assignment. All right, well, how many 1's make 2? 2 of them do. And we didn't change this 2 here to get here, so there's only 1 sulfur being used. Okay, clear that off, do that again. Once again, +1 and -2 don't match, so that has to be +2 -2. How many 1's make 2? 2 of them do. And now we can ignore the oxidations and simply copy the letters over. So K2S, potassium sulfide. All right, look at number 4 right below. Hey, you know what I see? +1 -1, already done. So this formula is lithium bromide, LiBr. Haven't done number 13 yet. Here we go. Hey, you know what? Just like number 11, that's +2 -2, nothing more to do. So this is CRS. Now, on number 14, just like we saw 11 and 12, 14 came out to be Cr2S3, and that's because chromium is a transition metal with multiple oxidations. And that's why we sometimes get, with the same elements, slightly different subscripts, because the oxidation numbers are going to vary, kind of like the isotopes, meaning the neutrons, vary. All right, I'm going to clear this off and scroll down a little further. Okay, so we're going to do questions 9, 10, forgot to turn on the drawing, 9, 10, 19, and 20, and I'll save the rest for you to try on your own. All right, so number 9, we have nickel and oxygen. The oxidation numbers are given. Sometimes they are, sometimes they're not. Whenever they're not given, just look on the charts. You see on page 440 in the book, the common oxidation numbers of some elements, and the handout also. But at least this time, we're given the oxidation numbers. Nickel, +2, oxygen, -2. Does that already make 0? +2 -2, nothing more to do. So it takes only one of each element to give us the formula, nickel oxide. Number 10, nickel's a transition metal with more than one oxidation. So now we have a nickel +3, oxygen -2. We can do the little switch trick and put this 2 over here and this 3 over here and be done. Ni2O3. And then reduce if necessary. Of course, 2 and 3 won't reduce. Again, though, that's because the LCM, the least common multiple, is 6. So +3 twice is +6, and -2 3 times is -6, and that's going to give us the 0, meaning nickel 3 oxide is the answer to number 10, Ni2O3. All right, number 19 and then number 20, and I'll leave the rest of that section for you. Manganese plus 2, bromine negative 1 does not equal 0. But we can look here and see that we can easily bump a 1 up to a 2. If we had 2 bromines, that would be a negative 2 to match that positive 2. That will give us 0. So the answer is simply MnBr, and you put the 2 there. So there's your answer. That's manganese 2 bromide. Number 20 will be manganese 4 bromide. How many bromines at negative 1 will it take to match a manganese? Negative 1, how many times will give us negative 4? 4 times. So I simply put my 4 there. Again, now I can ignore the oxidation numbers and simply copy this over. MnBr4, manganese 4 bromide. Because remember, that's now plus 4, and that's negative 1 4 times to make it negative 4. So there is your answer. All right, let's move on now to worksheet 55. Now with worksheet 55, we're talking about binary ionic bonds, which means we do not use those prefixes you learned about with the covalent bond. We'll come back to those on the next assignment or so. But look here, all we have to do now is copy the names. See the barium? That's all I have to do is write barium. Cl is chlorine. Now, since this is an ionic bond, we don't really have to worry about the 2 when writing out the words. Just remember, though, in the ionic bond, the last name is going to become IDE. So instead of chlorine, it's barium chloride. All right, number 9 I've already finished. Here's Ba again. Barium, since it's ionic bond, we don't say tribarium, just barium. So we can kind of ignore the subscripts when we're simply turning these ionic bonds into their words. P is phosphorus, but remember it becomes phosphide. So this answer is barium phosphide. All right, I'm going to clear this off. We'll do a couple more. All right, now I'm going to try to do it on the keyboard and type it. Okay, so I'm going to go to number 2 and notice the 2 elements involved. There's sodium and fluorine. Okay, so for sodium and fluorine, this may not be in red, but that's okay. I'm going to move the space over a little bit and I'll try to get it away from there. All right. What element is Na? That's sodium. So all I'm going to do is type sodium. Okay? Don't worry about the capital letter. That's what happens when I try to type it on the iPad. F is element number 9, fluorine. But remember, IDE. So just type it. And this one's a little tricky to spell. This one's U, then O. And remember, it's just INE. I forgot to put the IDE, so sodium fluoride. And again, we don't worry about the subscripts when we already have the formula for an ionic bond and we're writing the words. So let's go up to number 7 now. Okay, number 7. All right, do a little spacing. Okay, what is that K right there? Element number 19, you'll see K is potassium. S is sulfur, but remember the IDE. S-U-L-F-I-D-E. So number 7 is potassium sulfide. All right. How about calcium oxide? Well, once again, all I have to do is get the names. Ca is calcium, C-A-L-C-I-U-M. Oxygen, remember the IDE, the second name, this will be the nonmetal, will become IDE. So O-X-I-D-E, calcium oxide. All right, so that section, I'm going to let you finish off on your own, and I'm going to scroll down to the bottom section, and there's a little bit more to it you're just about to see. All right, now you read the directions here and be careful. This says these names read need Roman numerals, and that's because you look at the metal, copper, copper, iron, iron, chromium, chromium, and so on. These are transition metals with more than one oxidation number, so they can combine with the same atoms in slightly different ways. So to identify them, as I said in the notes, we put a Roman number after the metal's name, and you see number 13 is already finished. Well, how did that happen? Well, remember, since copper could be either +1 or +2, and I'm looking at the chart to see that copper could be either +1 or +2, what I have to do is go by the bromine first. So that bromine is always going to be -1. Now I know on one of the charts it says bromine has more than one oxidation number, but almost always, and for everything we're doing, bromine's going to be -1. So I put that bromine right here. That means copper has to be +1 to give us our total of 0. And remember, the oxidation number being used is the Roman number. So copper 1 bromide. So if I look at number 14, since bromine is -1 twice, bromine's going to be total of -2. Bromine's not changing. It's going to be -1 for everything we're doing. That means copper has to be +2, and that is one of the possibilities for copper. That will give us the 0. Now my writing would be a little sloppy on this, but that's okay. So it's copper, and because we came up with a 2, we're going to say copper 2 bromide. The last name's still going to be IDE. Very sloppy? Oh well. Let's see if I can clean that up a little bit. It just makes it a little realistic because I don't have a whole lot of room on here to write. Okay, look at number 16, which is already done. Once again, iron could be either a +2 or a +3. Well, oxygen's always going to be -2. And you see here, -2 times 3 is going to give us -6. It's a little down off the screen a little, but I can write it there. So that means iron has to be a +6, and since there are 2 irons, each one's going to have to be +3. Well, remember 3-2 switcheroo? We can kind of do that too, and that 3 here on the oxygen would come up here. And that would tell us that the +3 is the Roman number. So this is iron 3 oxide. Okay, I'm going to do 17 and 18 and leave 19 and 20 for you to do. All right, chlorine is always going to be -1. So twice would make it -2. That means chromium is +2. That gives us our 0. So this will be chromium 2 chloride. And I know I don't have the greatest handwriting on this. All right, number 18. Since chlorine is -1 3 times, that's -3. That means chromium has to be +3 to give us the 0. That means this is going to be chromium. And because the oxidation is +3, we call it chromium 3 chloride. Okay, I'm going to stop here and let you finish up the rest of this. And we'll see you next time for the next wonderful, exciting lesson about chemical formulas.